Hi and welcome to the video training of RabbitMQ. In this video training we will be working at work queues. In this video we will create a work queue that will be used to distribute time-consuming tasks among multiple workers. The main idea behind work queues, that is task queues, is to avoid doing a resource-intensive task immediately and having to wait for it to complete. Instead, we schedule the task to be done later. We encapsulate a task as a message and send it to the queue. A worker process running in the background will pop the tasks and eventually execute the job. When you run many workers, the tasks will be shared between them. This concept is especially useful in web applications where it's impossible to handle a complex task during a short HTTP request window. We will be sending strings that stand for complex tasks. We don't have a real-world task like images to be resized or PDF files to be rendered, so let's fake it by just pretending we are busy by using the time.sleep function. We will take the number of dots in the string as its complexity. Every dot will count for 1 second of work. For example, a fake test described by hello ... will take 3 seconds. We will slightly modify the send.py code from our previous example to allow arbitrary messages to be sent from the command line. This program will schedule tasks to our work queue, so let's name it new_task.py. So let's go to command line and projects Python and RabbitMQ. Okay, we have our first folder, that was hello world. I'm going to create work queues. Okay, sudo chmod -r work queues, and we are into work queues. Okay, I'm going to create a folder, file new task.py. okay, and here we are going to use import this message equals join system dot argument. These are basically the parameters that we will receive from the command line. Parameters, if it's not fine, we will say hello world. Okay, channel dot basic publish exchange goals. Okay, and routing. Okay. Okay, and routing key equals hello, and body equals message. This message is basically this variable that we will be printing or sending in the queue. So here we are going to say print x sent %r %message. Okay, save the program for now. And now our old receive.py script also requires some changes. It needs to fake a second of work for every dot in the message body. It will pop messages from the queue and perform the tasks. So let's call it worker.py. So I'm going to create a new file called worker.py, and we are going to write import time. We are going to define a callback function which receives a channel, a method, properties, and body. Okay, print double quotes x received %r percentage body dot decode. Okay, and we are going to use time dot sleep function, body dot count, and we will be using the dot to use time dot sleep. Print x. Done. Let's save this file. Now let's move next. So, round robin dispatching. One of the advantages of using a task queue is the ability to easily parallelize work. If we are building up a backlog of work, we can just add more workers and that way scale easily. First, let's try to run two worker.py scripts at the same time. They will both get messages from the queue, but how exactly? Let's see. You need 3 consoles open. 2 will run the work.py script. These consoles will be our 2 consumers, C1 and C2. So what I'm going to do is I'm going to open 3 consoles. Okay, now I have 3 consoles open. First I'm going to run python worker.py. Okay, waiting for messages. Okay, okay, basically we needed to copy some code from our previous video training in this playlist of RabbitMQ. That was the channel.basic consume command and the waiting command that starts consuming, and then we have the interrupt, keyboard interrupt, or the system exit code. So we need this in the worker as well. Now we can go and start python.work. Here we can define the channel on the top of the callback function. Okay, save it. Okay, connection pika is not defined. Okay, we need to import the pika library as well. So when is this the basic step that we need to run the RabbitMQ server in order to run our code, because our queues will work on the RabbitMQ Docker server. Okay, now we have it up and running. Now we can start the code. We have python worker.py. okay, you see we have waiting for messages. To exit, press Ctrl C. Let's go to another window and we are going to start another instance, worker.py, and waiting for messages. To exit, press Ctrl C, and in shell 3 we'll be running new task.py, python new task.py, and we are going to add some code because it is missing channel definition. Okay, worker, and here is the new tasks. We haven't defined the channel here, so we need to do that. Okay, let's start the new task again because pika is not defined. Okay, we need to add pika as well. Save and start again. You see it has sent the string hello world. Now if we go to our 2 terminals, we see one of them have received hello world but the other haven't. Okay, let's say hi there, and you see it has received hello world and hi there string, but the first one have received hello world, because we have added a time.sleep function. The second terminal will receive hi there message a bit late. So if I send the third message again, now the second one have received the third message, but the first one haven't. So this is working on round robin algorithm. Let's see what is delivered to our workers. So as you can see, we have first message, third message, fifth message for the first worker, and second and fourth message for the second worker. By default, RabbitMQ will send each message to the next consumer in sequence. On average, every consumer will get the same number of messages. This way of distributing messages is called round robin. Try this out with 3 or more workers. Okay, let's look at message acknowledgement. Doing a task can take a few seconds. You may wonder what happens if one of the consumers starts a long task and dies with it on partly done. With our current code, once RabbitMQ delivers message to the consumer, it immediately marks it for deletion. In this case, if you kill a worker, we will lose the message it was just processing. We will also lose all the messages that were dispatched to this particular worker but were not yet handled. But we don't want to lose any tasks. If a worker dies, we'd like the task to be delivered to another worker. In order to make sure a message is never lost, RabbitMQ supports message acknowledgements. An ACK is sent back by the consumer to tell RabbitMQ that a particular message had been received, processed, and that RabbitMQ is free to delete it. If a consumer dies, that is, its channel is closed, connection is closed, or TCP connection is lost, without sending an acknowledgement, RabbitMQ will understand that the message wasn't processed fully and will requeue it. If there are other consumers online at the same time, it will then quickly redeliver it to another consumer. That way you can be sure that no message is lost, even if the workers occasionally die. There aren't any message timeouts. RabbitMQ will redeliver the message when the consumer dies. It's fine even if processing a message takes a very long time. Manual message acknowledgements are turned on by default. In previous examples, we explicitly turned them off via the auto ACK true flag. It's time to remove this flag and send a proper acknowledgement from the worker once we are done with the task. Okay, let's look at a callback function. So channel.basic_consume function is accepting a queue name, that is hello, and on message callback parameter, which defines a callback function. Using this code, we can be sure that even if you kill a worker using Ctrl+C while it was processing a message, nothing will be lost. Soon after the worker dies, all unacknowledged messages will be redelivered. Acknowledgement must be sent on the same channel that received the delivery. Attempts to acknowledge using different channels will result in a channel level protocol exception. You can visit the document guide on confirmations to learn more. So what we are going to do here is we are going to add some code in our worker.py file, and we can add it here somewhere. Received body dot decode time.sleep print text done, and channel.basic.acknowledgement. Okay, here we can add this code: ch.basic ACK delivery tag equals method dot delivery tag. Here we can change our code a bit to body.decode, and we have added time.sleep here. So body dot count, and here we have dot, and here we say print x done. Okay, let's save this and let's stop our workers. Stop, it's already stopped new task, so I'm going to run the worker again and another worker again, and let's send a new string, call hello there world. Okay, sent. Okay, here we have an exception received, you hi there world. Here we haven't received any message yet, so it says time is not defined. So let's define a time here, save it, let's run it again, stop this and run it again, and let's send it again. Okay, this time says channel.start consuming processing precondition failed unknown delivery tag. So there is an issue with our delivery tag right here, and in the new task, if we go, we are sending exchange hello world. Okay, and there isn't a delivery tag here exactly, so this method dot delivery tag properties body dot count. Okay, save this file and try it again. Okay, now the other one have received it, but it's again giving message on unknown delivery tag. So for now we can remove delivery tag, or let's try to commit it and try it again, see what happens now. Okay, okay, so we have an issue here with the delivery tag. We will revisit it again. For now we can run our program as it is, and it's okay, it says waiting for messages to exit, received, you hi there, done. Okay, let's look at message durability. We have learned how to make sure that even if the consumer dies, the task isn't lost. But our task will still be lost if RabbitMQ server stops. When RabbitMQ quits or crashes, it will forget the queues, the messages, unless you tell it not to. Two things are required to make sure that messages aren't lost. We need to mark both the queue and messages as durable. First, we need to make sure that the queue will survive a RabbitMQ node start. In order to do so, we need to declare it as durable. So in the code of new task, we can say channel.queueDeclare, and we need to say durable equals true. Okay, so although this command is correct by itself, it won't work in our setup. That's because we have already defined a queue called hello, which is not durable. RabbitMQ doesn't allow you to redefine an existing queue with different parameters and will return an error to any program that tries to do that, but there's a quick workaround. Let's declare a queue with different name, or example task queue. So we have a channel.queue.declare queue task queue durable true. This queue declare change needs to be applied to both the producer and consumer code. At this point, we are sure that the task queue won't be lost even if RabbitMQ restarts. Now we need to mark our messages as persistent by supplying a delivery mode property with a value 2. So if we go here and we can change our channel name to task queue, and as well task queue we need to do is in our worker as well. So task queue, and okay, and where we are declaring the channel, we need to say durable equals true here, and here we have already done that. And where we are publishing the channel, we need to add the properties equal pika dot basic properties, and we are going to pass delivery mode equals to. This makes message persistent, and here we have closed the main braces. Save this file, and now if we go to our worker, we can save this file, and so in the new task we have task queue channel.basic, and we have the properties mode in our worker. We have the task queue consume auto acknowledgement. Now let's run our program again. So let's run the worker 1, worker 2, and our new task. Okay, it has delivered it, but again there is an issue with the delivery tag. So this is the issue point here. So now we can omit it, and let's start again, and says pre-connection, and okay, now we have delivered hi world, and let's deliver another message, and this will be delivered to second consumer. Okay, you might have noticed that dispatching still doesn't work exactly as we want. For example, in a situation with two workers, when all odd messages are heavy and even messages are light, one worker will be constantly busy and the other will be doing hard work. Well, RabbitMQ doesn't know anything about that and will still dispatch messages evenly. This happens because RabbitMQ just dispatches a message when the message enters the queue. It doesn't look at the number of unacknowledged messages for a consumer. It just blindly dispatches every nth message to the nth consumer. In order to defeat that, we can use the channel basic QoS channel method with the prefetch count 1 setting. This uses the basic.qos protocol method to tell RabbitMQ not to give more than one message to a worker at a time. Or in other words, don't dispatch a new message to a worker until it has processed and acknowledged the previous one. Instead, it will dispatch it to the next worker that is still not busy. So in the new task.py, we can say channel.basicQoS, and we can set it to prefetch count equals 1. Save this file. Now let's run our program, and it says sent, and you can see it's run again. So I'm sending multiple times, so these are evenly being delivered to the particular consumers. Putting it all together, so this is our new task.py file with all the code, and this is our worker.py. I have uploaded these both files to my GitHub repository, and I have shared the link to the GitHub repository in this video training description on YouTube, so you can easily clone this project on your local machine and run it on your own. So let's revisit our application architecture again. So first you run both the workers, Python worker, but first you need to run the RabbitMQ server. I'm using RabbitMQ Docker image, so you can run it by Docker run it RabbitMQ on this port, RabbitMQ 3 management, and in the first terminal I'm going to run python worker.py, so I have it up and running. Then the second worker, that is the second consumer, and then I'm going to run the new task, and here you can see it has received first message, and all the messages I'm sending are being evenly delivered to both consumer. So that's about it. Using message acknowledgements and prefetch count, you can set up a work queue. The durability options let the task survive even if RabbitMQ is restarted. So if you need any help, feel free to contact me at email umahmood@gmail.com, visit my LinkedIn profile or my Twitter handle. RabbitMQ is a bit tricky at first, but it's not difficult. It's very easy to implement and integrate in your current application. You just need to be focused and be careful on the settings you are doing in your RabbitMQ workers and producers. That are very important. So hope you have learned something from this video tutorial. Let's see you in next video training of RabbitMQ.